So welcome all to Dr. MDS Academy. Here I am going to show you few slides related to different pairs having different degrees of freedom. So see in the first GIF image, we are having three axes X, Y and Z. X axis, Y axis and Z axis. Here, this is the case belongs to the revolute pair, turning pair. So T indicates translations motion and R indicates rotation motion. See in this first one image, revolute pair. So only Rx is present, means this member is rotating only in this way. Theta x means about this axis. X about is x axis, that is theta x, or here it is indicated by Rx. This member is possible rotating. Okay, so this only single input we are providing, so this case belongs to the 1 degree of freedom. Now next, take another conditions, prismatic pair or sliding pair. Again we are having a only this member is rotating in this way, possibility of the body sliding along this x-axis, along this x-axis. Okay. So only Tx is present. Translation, only sliding is possible. That's the name is sliding pair in x-axis. Okay. So again, remaining variables are 0. Okay. So all are 0. So only one single input in x direction is possible. So again, this is the case for the 1 degree. Now let's take another example. Screw pair. Here we are rotating this screw, okay, about this x-axis, okay, and uh, by default it is translation. Okay, so mainly this body is rotating in this axis along this x-axis. Okay, so that's why Tx is present here, and by default it is giving Rx. So again it is case of Rx, 1 degree of freedom. Now take another. In the next slide, we are having a pair with 2 degree of freedom. Means two different separate inputs we are providing to obtain the constrained motions. Okay, or to bring the mechanism into useful engineering purposes. See here in the x-axis, this member is along translating. Okay, that's why Tx is present here, and also possibility of rotating this object along this Rx also. Okay, Tx also. So two different variables, okay, are present over here. That's why this is the case for the 2 degree of freedom. Take second one image. Okay, spherical with pair with pin. See here, this is rotating like this. Okay, means about the y-axis. That's why Ry is present. Similarly, this is also like this doing. Okay, about this z-axis. That's why Rz is present. This is the Rz case and this is the Ry case. Okay, you can say like this, theta z or theta y. Okay, next slide showing the pair with 3 degree of freedom. See here, this is about the y-axis, it is rotating. Okay, that's why Ry is present. About the x-axis, this member is rotating, so that's why Rx is present. Here also about the z-axis, this member is rotating, that's why this is the case for the Rz. You can also think like this. Okay, theta about x, theta about z, and here theta about y. Okay, that's why the three different rotations are presented and translation are absent. Now here the planar contact pair. See here, this what is happening along this z axis. Yes, it is translating along this y. Okay, See here, yes, it is translating or doing the linear motions. Okay, so this is the TZ case, this is the TX case. Yes, it is rotating also. Yes, it is rotating about this ry. Okay, so three different variables are present. Okay, 1, 2 and 3. So this is, that's why this is the case belongs to the 3 degree of freedom. Now 4 degree of freedom. Next slide is, see here, x, y, z, three axes we are having. See here, along this x axis it is doing translation motions. That's why tx is present. It is rotating about, yes, it is rotating about y also. Okay, that's why ry is present. Is it rotating about x also? Yes, it is rotating about the x also. Okay, and this one is present, this one is present. Z, is it is rotating about the z? Yes, it is rotating about, that's why it is doing rotation like this. Okay, that's why rz is present. So we are having 1 2 3 4. Okay, four different separate inputs are required to obtain the constant motion or to bring this mechanism, okay, to use kinematic chains into useful engineering purposes. Okay, now this one, the second GIF image showing the cylinder and plane pair case. The, yes, it is rotating, doing translation along the x-axis. Okay, doing rotation also. Okay, yes, it is doing rotation about Rx also. See here, rotating. Yes, it is. So these are two variables present. About the y-axis, is it rotating? Yes, it is rotating. See here, yes, it is rotating. So this is also present. About the z-axis, is it translating? Is it? Yes, it is translated. Okay, RZ. So how many different variables are present? 1, 2, 3. 1, 2, 3, 4. Four different input variables are required to obtain the motions. Okay, different four motions are present. Okay, so this belongs to the 4 degree of freedom. Now the next slide showing the ball and plane pair. What is that? See here. Yes, it is. Yes, along this z, x doing translation. Okay, now yes, it is rotating about ry also. Okay, yes, it is translated along tz also. Okay, so tx present. Okay, tz present. Okay, ry present. Is it is rotating about the x also? Yes, it is. Yes, it is rotating about rx also. Okay, so this is also present. Is it rotating about z axis also? Yes, it is rotated just now. rz, see here, ऐसे rotate किया. Okay, now that's why how many different variables present? Okay, see here, the different variables present over here is total 5. 1, 2, 3, 4, 5. So two different translation motions and three different rotations. Okay, so total giving is 5 degree of freedom. Now the last case is pair with 0 degree of freedom. 0 degree of freedom means there is not possibility of rotating or providing the relative motion between the two links. So this link is 1, this link is 2, and this is welded here. Okay, so we have permanently fixed these two, 1 and 2. So there is no possibility of doing providing any translation or rotation motion. Okay, so this is the case for the structure. or these type of motions, this type of kinematic pairs are used in the bridges, trusses, roofs, okay, uh, structures where no relative motion between the link at 1 and 2 or between the two links are possible. So see here, all the translation motions are 0 here, all the rotation motions are 0 here. So there is no possibility or we cannot provide any input so the to get the relative motion between the link of 1 and 2. So thank you all. So now the next we are going to start kinematics of machine, okay, in the upcoming lectures. So stay connected with this channel. Thank you all.